Hello. Welcome to Biological Foundations of Behavior. If this isn't the course that you've signed up for, you're welcome to stay. You just won't get credit for it. So it's neur/psych 2200. For those of you that aren't that aware, this means that it's a cross-listed class. What that means is that we have a combination of psychology and neuroscience students in the same class. We also have a combination of in-class students, and if you haven't been tuned in yet to what's going on over here and here, is that we're actually being taped. So we have a whole bunch of students at home sitting with their beer or their coffee, enjoying today's lecture. So just so you're aware, this class is actually comprised of close to 400 students. We have 100 students in class and close to 300 students that are online or distance learners. Some of these students come from as far as Pakistan. Some of them are actually local students that just can't access the in-class section. So just so you're aware, we have a lot of students in this class. You are just the in-class portion. So throughout the term and as I'm lecturing, I will often speak to my video students, hello, and hopefully engage them somehow. They can't talk to us, but we can certainly talk to them, either in this camera or in this camera. Also, what that means is do not be shy to speak in class because you're afraid of being on camera. I do this all the time. Trust me, no one's watching you. No one's watching me. They're all watching something else. At least that's what the stats say, if you actually look at who's accessing the video. I'm just kidding. They are watching, but they're not looking in the class and peering at you. Hopefully, they're focusing on me and what's happening on the screen. So I do like a lot of dynamism in my classes. I like a lot of discussion, and I'm going to try as best as I can to encourage you to speak in class despite having the camera there in front of you. So it's good training for any of you who want to eventually have a career as a celebrity actress or actor. It could happen with your degree in neuroscience. Anyway, so welcome. Just a little bit about what we're going to do today and so what to expect. You should have all accessed this course already on CU Learn, and therefore should have in your hot little hands a copy of the lecture and the course outline. How many of you here have not accessed this course on CU Learn? Okay, you need to be doing that ASAP, which stands for as soon as possible. There is actually a lot of statistics that show that students that do not access their learning management systems do not do as well as students that are accessing the CU Learn or WebCT. If you were previous to the CU Learn, you need to be accessing your course materials. So I do strongly encourage you to get onto CU Learn immediately. Actually, not right this second, but as soon as you leave here. If you're having problems logging in, let me know, and I can certainly help you with the CU Learn.
Is CU Learn just like the new version of WebCT?
CU Learn is not a new version of WebCT, but it's replacing WebCT. So for those of you, I know there's a lot, there's quite a range of you in this class from some first years to fourth year. WebCT is going the way of the dodo. It's a horrible system, as you all probably are aware if you've used WebCT. So we are rolling in CU Learn. Some of your profs may be still using WebCT. They have access to that until May 2013. But we're trying to encourage, and I say we, the royal we, the EDC, is trying to encourage professors to move to CU Learn. So what that means, unfortunately for you, is that some of you may be accessing your courses via WebCT and some of you are accessing them via CU Learn. So you'll have two places to go to. But yes, it's replacing WebCT. There's a lot of aspects to CU Learn that are much, much better than WebCT, and I'll talk about some of those throughout the term. So we're going to go over the course outline very briefly because I expect you to have downloaded the course outline, printed it out. Yes, we're going to kill some trees because I want it in front of you throughout the term. I find often students have many questions about the mechanics of the course that are answered in the course outline, and I as a professor get very frustrated with that, and I make very angry noises when I have students that ask me questions that are answered in the course outline. I spend a lot of time making my course outline. I'm very anal. You'll see this throughout the year. And so a lot of the stuff that's in there, I really make sure that it is comprehensible to you as the student. I'm going to highlight some of the points in there today, but certainly you should take the time to go through the course outline, read it very carefully, especially the section on plagiarism and academic offenses, and make sure that you are comprehending everything that's in there. So we'll go over the course outline. We'll go over some of the course expectations. What should you expect from me as a professor? What should you expect to be learning in these next 13 weeks? We will also talk a little bit about the exams because everybody is concerned about exams. So I'll talk very briefly about what the exam structure, format, etc. is, and a very brief introductory lecture. What I do expect is that my students have downloaded the lecture ahead of time. I want you to either have it on your laptops or have it printed out in front of you, and you are going to make additional notes to the lecture content. What you see in front of the screen, what you see printed out, the PowerPoint slides, is not everything. What comes out of my mouth sometimes are some real gems, sometimes not. But I add to the lecture material. And when you are examined, it's not just enough to read the PowerPoint slides. I cannot emphasize this enough. You need to be actively engaged with the material. Too much nowadays, we are giving students PowerPoint slides and saying, go to town. And students think, I have all the material, this is it. No, no, no. You need to be writing notes and adding to that course content. So I expect you to be downloading the PowerPoint slides and bringing them to class. And that means that I can go at a specific pace, because if students haven't downloaded the slides, they're desperately trying to write everything that's on the screen and saying, whoa, 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 slow down. That's not the way I lecture. I expect that it's in front of you, so it's at a very specific pace. So who am I? I don't think I've had any of you as a professor before, unless I've taught you Psych 2001. Psych 2001 in fall 2010, which is right before I went on a maternity leave. I see some of you are my 1201 students, so some of you I have taught yesterday. Is there anyone that has had me as a prof before for a full class? Yay! Which one? 3 years ago.
2 years ago before you went on.
So Psych 2001, right. So we have one sole survivor of Kim. No, the stats are generally better than that. So my name's Kim. Please do call me Kim. Don't call me Miss, Ma'am, Madam, Mrs., Yuck. I don't like any of those. I am married, but only very recently, and Mrs. seems a little weird. So call me Kim. If you're not comfortable using a first name basis, you can say Dr. or Professor Hellmans. That's all good. A little bit about my background. I do have a PhD. I started out many years ago at McGill University as a Bachelor of Arts student with a major in psychology. So yes, what this means is I have reinvented myself as a scientist, because I now teach for the Faculty of Science. That is to say that psychology, neuroscience really emerged as a discipline outside of psychology, right? So right from the beginning, even though I was a BA student, I really was fascinated with the brain. I was really fascinated with the neuroscience aspect of psychology. So I finished my degree. I ended up going to Queen's University in Kingston and doing my master's and PhD in the subdiscipline within the Department of Psychology of Behavioral Neuroscience. What I was really interested in as a researcher was the biological basis of addiction. I was really fascinated with the idea that some people develop, we all experiment with drugs, well, most of us do. I know my first time I ever had a drink, I was 15 years old. I drank one wine cooler and I was totally blasted for the rest of the night. It was pink, I remember, because my friend Mandy Oman puked up pink most of the night. But I am not an alcoholic, so why is that? How is it that some people, when they have their first drink, it leads to a pattern of alcoholism? So I was looking at this from an animal models perspective. I was using rats, which are the #1 species that we use in neuroscience, apart from mice. And so I used animals to study the biological mechanisms underlying addiction. This is all to say that, very sadly, in my last, so I finished my degree, my PhD, at Queen's. I went on to Cambridge University and I did a postdoc. Don't worry what that means, but essentially it's additional training. I finished my postdoc at Cambridge, went on to UBC to do yet another postdoc, because who doesn't want to live in Vancouver? And at that point I developed a very vicious rat allergy. Very sad, because essentially what it meant was I was no longer able to work in the lab. So I made a very difficult decision to leave my research career. And now at Carleton, I was hired in 2008, and I am a full-time instructor. And so what that means is my bread and butter is teaching. I love to teach. I love to talk about neuroscience. I love to express the enthusiasm I have for the brain and the neurons. And so that is my full-time job. I also still do some collaborative research projects. I do occasionally take on honor students, and I'm still publishing, but my main role here at Carleton is teaching. If you want to get a hold of me, the preferred mode of communication is by email. I teach 3 classes this term, but I'm responsible for 5. What that means is I'm very rarely sitting at my desk. So if you want to call me, certainly my phone number is listed on your course outline, but very rarely will you actually catch me sitting at my desk. So if you email me, I will get back to you. I'm fairly good on email. I usually reply with students between a day or two. Obviously, weekends give me a little bit of time to catch my breath, and I like to spend time with my family. When you do email, because of the number of students that I teach this year is in excess of 800 in 3 classes, please do put your course code somewhere in your email, be it the subject heading or the body of the text, just so it cues me to know what student you are, and so I'm answering your question appropriately. Does that make sense? It's also helpful to put your name. It's amazing how many students don't. I've actually had almost every single student that has called me on my office line has never said their name. Hi, I'm in 3rd year neuroscience, blah, 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 blah. And then they're like, can you get back to me? And I'm like, who are you? So if you call me, also say, hi, I'm so-and-so. Please avoid text-type emails. There's nothing more irritating than receiving these kinds of emails. I do text, yes, I use the word you, I use the letter U in place of you, yada yada. But as far as I'm concerned, we're in a professional relationship, and now is a good time to practice the professional skills that you're going to have eventually in the future, because you would never text-type email your boss. So use punctuation, capitalization, full sentences, always appreciated. So what to expect from me as a professor? I've been teaching for 9 years. I've taught this course. This is my 2nd time here at Carleton, but I've taught the same equivalent course at UBC and at Queen's. I am a very organized professor. I like to think that I am. I make my expectations very clear from the outset. If you want a glimmer as to what other students think of me, you can always go on ratemyprofessor.com. I don't tend to look at those just because sometimes they make me want to grab a few glasses of wine. But there are some pretty frank comments on there. So you can certainly talk with your fellow students or check it out. I'm also, I think I wrote this. No, I didn't. And many of you, I'm sure, are aware of this. I'm also the chair of the undergraduate program here at Carleton. And what that means is I'm responsible for the entire undergraduate program if you're a neuroscience student or a neuroscience and mental health student. So I know many of you are psych students, so this doesn't apply to you. But you neuro people, if you have any problems or questions related to your degree, I'm the one that you should come see. If you have questions about your courses, what to register for, your audit, I'm the one for you. So not only do you have me as your professor, but you also have me as the undergraduate chair. So I will serve dual roles for you. And this all brings me to say that if you want to come see me, so you can certainly email or call me, but if you actually want to physically have a conversation with me, you can certainly come to my office. And I live in SSRB, which is the Social Sciences Research Building. It is basically the boondocks of Carleton campus. It's located at the very northeast tip here in between, at the corner of Library Road and University Drive, right before you hit Colonel By. If you hit the canal, you've gone too far. It's very, very hard to find. It's like obscurity. I can't even, yeah. I've had many students get lost, which is sometimes good. But if you want to see me and you're not sure how to get there, just ping me an email and I'll give you the directions of it as best I can. Basically, we're in this building. To access it via the tunnels, you just go through that little passageway. If you see, you go past the elevators, there's a bunch of seats and then a passageway where there's a bunch of chairs. You keep going and follow the signs to SSRB. My office hours are Thursdays from 3 to 4 p.m. and I have office hours today, so you're welcome to pop in from 1:30 till 3. So immediately after this class, not immediately, let me go to the bathroom first and take a few breaths, but at 1:30 to 3 o'clock. So reasons to come see me. Course content you're struggling with, having some issues generally, and are feeling like things are not going well, and you want me to be aware of that. You don't know what to do with your life, and you're unsure, what do I do with a career in neuroscience? That's part of my hat as the undergrad chair. I'm happy to talk with you about that. Or just to come and introduce yourself and tell me a little bit about yourself, and we can just chat about how awesome the brain is. I'm happy to do that with you. So don't be intimidated. I would like to think that I'm fairly non-intimidating, and I do really love getting to know my students. I just got married a month ago, 2 months ago, And two of my students were actually at my wedding. So one that I taught 10 years ago, one that I taught 8 years ago. So you can see I tend to develop very close relationships with my students, of course, within a certain line. But I love, this is obviously why I went into teaching, is because every one of you has a story, and I love being a part of that story for one little chapter of your life. So do come see me. Okay, this course. As you're aware, the course text that we're using is The Introduction to Brain and Behavior by Kolb and Wishaw. It's the 3rd edition. Yes, the 2nd edition is fine. If you can get your hands on a used copy, absolutely do use it. It's totally fine. You can get it at the bookstore, and I think Haven Books probably has a bunch of used copies because we teach, I think this course alone, we teach probably close to 800 students a year. So definitely there's going to be some used ones floating around. How to use the textbook. I believe in the course outline I have a little blurb about this. Sometimes I get confused between classes. Oh yes, here we go. How much do I need to know from the textbook for the exams? Page 1 of the course outline. I get this question every year, every term, and so this is why this time I've actually decided to include this in the course outline, because students really, and it's not, I don't blame you, you get a little like crazy with detail. You're like, do I need to know the box 7.1 on schizophrenia? Read through this. If you have any questions, feel free to ask me. But essentially, the text is a resource. What happens in lecture is primarily what you're going to be tested on. Everything that happens in these 4 or 5 walls, 6 walls, is basically what I expect you to know. The textbook obviously is going to have most of the information in there and may explain it in a way that I couldn't do as well, right? So I usually say to my students, if you're an A student, you probably don't need the textbook because you probably are going to get as much as you need from my lecture content. If you're a B student, it's a little iffy. C or D student, definitely get the textbook because it's just going to be another way for you to gather the information. Some material is not going to come from the textbook, so I do like to add in a little bit of novel content here and then. I do follow the textbook more or less with the chapters that you're expected to know in the content, but sometimes I'll include like video clips or current research in a specific discipline that's not in the textbook. So that's going to be found in the lectures. And oh, old slide. It says there that it's going to be posted on WebCT. No, you guys at home, wake up. Posted on See You Learn. So I generally will post, what class? We're Friday? Class Wednesday, Friday. So I'll generally post the lectures at least a day in advance. And I'm trying to figure out if See You Learn has a way to let you know when I've posted the lectures, because that's always handy, right? To send you a quick email and say, your prof has uploaded the lecture, and that way you're not always having to check. I'm pretty good at getting it up there. If for some reason the night before the lecture or like it's 8:30 in the morning and you're like, where's the lecture? Please email me and let me know, because it could happen. I think it happened a couple times last year where WebCT was acting up and I thought, well, I'd gone through the uploading process, but it actually didn't work. And so the students were a bit confused because there was no lecture. So there's nothing worse than me showing up and people were like, there's no lecture. And then I really have to take it slowly and while people take notes. So please let me know. Alrighty. We are a team here. I am your prof, but we have some amazing teaching assistants that are here to help you. They are here today, for the most part, to introduce themselves. But very briefly, I'm going to talk about what their role is. Essentially, this year, what I've decided to do is I've assigned a very specific group of students, according to their last name, to a given TA. And I don't believe I've posted that yet, right? No. So I'm going to do that ASAP. But basically, if your last name falls between X, AA and I can't remember what it is, LL, you're going to have TA X, right? What that means is that for the entire term, that is your TA. If you have problems with the course content, you need a little bit of extra help, and I might be too busy to meet you on that given week or what have you, that's when you would email your TA and say, hey, can we meet? Or can we do, for you guys at home, if you're in Pakistan or Toronto or Hamilton, what that means is that you can maybe arrange a phone call with your TA, or we have this new technology on CU Learn, which is called Big Blue Button. And essentially what that means is that you can do it's very similar to a webinar with your TA. So you can say, hey, can we go on Big Blue Button at 7 o'clock on Friday? And your TA will log in, you will log in, and you can have a private chat session with your TA. So we're going to use Big Blue Button for all of you, and I'll talk about that shortly, but that's what that means for your TA. So you can meet with your TAs. Also, that TA is going to be marking all your exams. So say Rob's your TA, Rob will mark your midterm 1, midterm 2, and final. Now, some of you are probably going, but wait a sec, what if Rob is like really, really hard and Catherine isn't? Because he is, he's brutal. No, I'm just kidding. I go through and what I'll be doing is checking the averages of all the midterms and final to ensure that there's no significant differences between the averages. If it so happens that Rob's come up, 5 to 10% lower, then I will get Rob to remark all the exams and make sure that they're within the same range. Ha! Okay, so don't worry about that, right? We've got that covered. So what I'm hoping is that this will mean that you have, there's I think 50 or 60 of you assigned to one TA, but hopefully then you'll have a good relationship with that TA rather than saying, okay, I'm having problems, I'm going to email all 6 TAs, hopefully somebody's going to answer me back. Any questions so far? I'm like... It's like looking into the eye of the TV. I know you guys can't ask questions, but I'm looking at you anyway. Oh, yes.
Actually, you do have them assigned. So,
did I write them?
yeah, you do have them.
In my outline, did I?
Yeah.
Oh, see, I was smart.
Yes, you
Oh, yes.
last thing.
There we go. Thank you.
Yeah. So I am with Rob.
No, Rob's great. Right, yeah. All of these guys are great. Yeah, so, right. So, Brianne. Okay, so why don't we start? Brianne, come on up. Stand up. Yay. So why don't you tell a little bit about yourself?
Sure. Hi guys, my name is Brianne. I'm in my 3rd year PhD right now.
Oh, right, there's no... Oh, I think there's like a...
Okay. Okay, hi guys, I'm Brianne. I'm in my 3rd year PhD here at Carleton. My supervisor is Matthew Holohan. Some of you guys might have had him before. And I actually did my undergrad here at Carleton as well in science. So I've both taken this class before and TA'd for it. So if you guys have any questions, I'm always open and look forward to getting to meet some of you guys.
So Brianne is responsible for anybody with their last name beginning with AA to CHAF. So if you fall in between that, Brianne.
Lucky
Anyone
you.
there? Anyone here? Yeah, AA. Yeah, go. Yeah.
Hey.
So there you go. All right, Catherine Smith, who is not here, she's actually working for Health Canada up until the end of September. But she's fantastic. She was my TA for this course last year. She also works with Matt Holohan. She's in the process of finishing her PhD. She's also going to be giving, along with Rob, the review lecture for those of you that need a little bit of a primer on bio or chem. And I'll talk about that shortly. But she is TAing people with the last names beginning CHAS to FAI. So if that's you, Catherine is your TA. Kristen.
Here? Hi, I'm Kristen. I am a second-year master's student, and my supervisor is Kim Matheson. I did my undergraduate here at Carleton. I did take this class, but I've never TA'd it, so this is my first time too. So I'm excited to meet you all.
And Kristen is responsible for FAH to KEL. Any winners here? Don't be shy. It's all good. Woo! Rachel.
Hello, I'm Rachel. I'm a second-year master's student, also working with Matthew Holohan. And I did my undergraduate degree here in psychology and a minor in economics. So kind of like Kim, got a BA in psych, but going
You snuck in there.
the science route. Yeah, so I look forward to meeting you guys.
You too, you psych people. We will recruit you.
Yeah, we will.
So Rachel, did you say who you're working with?
Yep, Matt.
Okay, right. Is KEN to MIR. Yay, there you go. Shayna.
Hi, I'm Shayna. I'm my second year master's student, and I'm also in Matthew Holland's lab. You pretty much have our entire lab TAing for you.
I only get the best TAs. I actually request them. So
We're awesome. It's
Yeah.
a great place. I did my undergraduate at Memorial University of Newfoundland, and I did it in psychology, but in the sciences as behavioral neuroscience. And this is my first time taking the course, I guess, as well as TAing it. But I know stuff, so you can email me, and I'll help you out if I can.
why don't you have a new accent?
I'm
That
from
was not
St.
new for you.
John's.
Sorry,
No,
that was like.
it's like right on by, right? Yeah.
Yeah.
I can if I'm angry or I've been drinking. Other than that, I speak like a normal person, which is helpful on the mainland with you mainland folk.
So Shayna is MIS to SCH. MIS to SCH? One? Come on. Oh, they're all online. Oh, there. Okay. Yeah. If you don't know your last name,
It's not good stuff.
yeah, we're not in good footing. All right. And lastly, Rob. We always have the token male in psych, right?
Hey guys, my name's Rob. I'm a second year PhD student in neuroscience. I'm really not that bad of a TA,
No.
so don't be scared.
I was just
think
picking
I'm
on
pretty,
Yeah.
pretty easygoing. I've been at Carleton for 7 years now, since I started my undergrad here, so I've been here forever. If you want a tour, let me know. I'm in Dr. Jaime Anisman's lab, and we do research on stress and mental illness. And other than that, what else do I need to say? That's pretty much it.
Yes, I think
Yeah.
so. So Rob is SE to Z. Righty-ho. Excellent. So any questions about anything so far? So all their email addresses can be found in the course outline. Okay? And you can also email them actually in CLearn, right? So you hit compose email, and if you want to email Rob, you just type in his name and it should pop up. Alrighty. This is when I get stern. So, as I mentioned, I taught this course last year, and it was kind of shocking to me to discover that many of the students in the class were really not aware of the course content. I can't tell you how many times I didn't realize this course had biology in it. It's called Biological Basis of Behavior. What the fuck, okay? There is science in this class. I am a neuroscientist. I teach for the Faculty of Science. We administer the class. I know a lot of psychology students are perfectly competent, really love this material, are very excited to attack the brain. But I find a lot of the students, last year certainly, didn't realize. They thought that taking this class they were going to learn about how the brain changes in mental illness. We do 2 lectures on that. 2. So the majority of the course is really looking at the foundations of the brain. So what does the brain look like? Some neuroanatomy. How does it function? Neurobiology, neurochemistry. We discuss in detail what a synapse looks like. We go on in future lectures to talk about neurodevelopment, which is really, really tough stuff. Even I have a hard time understanding some of this material. Of course, I teach you down here. I'm not going to teach you at a level that is way too hard for you, but you should be aware that we talk about the brain the entire class. You're going to have to label brains in your exams. You're going to see pictures where you're going to have to say, this is the cerebellum, this is the amygdala. So there is a lot of science in this class. It is a challenging course. We are not clapping for credits. For those of you that think this is an easy elective, let me remove that from your mind right now. Of course, this is not to say, get out of here if you just want to clap for credits. I'm not discouraging you from staying in this class. I really hope all of you do. I'm just saying you need to be aware of what to expect in this class. So if you do not have a science background and are not a strong student, you may wish to reconsider this class if A's are important to you, right? If you're okay with the C, I'm okay with the C. If you're okay with the D, hey, fine, right? But you should be aware. So I do try very hard to have everyone feel comfortable with the material. Remember, I'm a BA student, right? Remember, I've been there. So I'm a very compassionate instructor, but I can lead you to water, I can't force you to drink. So you have to fulfill your part of the obligation as a student, which is to say you are going to study, you're going to show up to class, you're going to watch your lectures, not just the night before the midterm, and you're going to work hard to do whatever grade you want to get. So that's me being stern. And I did email you all, I know, to give you a bit of an advance of this, because I wanted people who really did feel uncomfortable to have the chance to drop the class before classes started. So I'm hoping that those who did feel uncomfortable have already taken their leave. So for those of you at home that are sitting, hopefully with a beer, because I wish I was having a beer right now, a note on cyber slacking. For those of you that have never taken a V or T section class, there are some additional challenges to this. Absolutely, they can be extremely beneficial because not only do you have the broadcast, you also can pay $50 to do the video on demand, which even the in-class students can take advantage of, which means you can download the lectures and watch them over and over and over again. Please don't post clips of me on Facebook. I had a few students do this last year. I was like, really? Oh my God. Okay, so you can watch me as much as you can. And whenever you want, be it midnight, 3 a.m., whatever, right? Do not leave it to the last minute. Any of you with a background in psychology, you know the ramifications of massed versus spaced learning, right? To try to read a textbook the night before the midterm, yes, there are maybe 1% of the population who have eidetic memory, which means you look at things and it's like a snapshot of a camera. There are some people who can do well with this type of learning. Majority of us cannot. And don't leave your lectures to watching them the night before the exams. We have data. We have data showing the Hail Mary students, the ones that I can do, how many hours? So 22 lectures, virtually, we're going to say close to 40 hours of lecture the night before the exam. You guys don't do well. You don't. Don't think you're going to be the 1%. No. So don't cyber slack, okay? You heard it here. So back to the science thing. I want to get a good grasp of how you guys are feeling. So throughout the term, I'm going to be using a technology known as Poll Everywhere. How many of you have heard of Poll Everywhere? Those of you in my 1201, we did it yesterday. Basically, Poll Everywhere is like using clickers, but it removes having to use the clickers. Instead, it means that you take out your cell phones, and like American Idol, you can text in a vote. So what I'm going to do in the next slide is I'm going to poll you all. And so pull out all your cell phones if you have them. And what you're going to do is I'm going to ask you a question, and you're going to text your answer to a specific number. So the question is, and you guys can answer too, certainly TAs, I hope it's not number one. What is your comfort level with the biological sciences? So in the to section of your text message, you text it to 37607. And if you're totally freaked out, in the body of the text, you type in 345536. I'm a bit nervous, but I think I can handle it. That next one, I've got a good background in biochem. I am a science whiz/nerd. Now, we're just doing this as a test run. Those of you at home, absolutely text in your answer, because I'm going to keep this poll open for the rest of the week, or we're Friday, all of next week. So I'd love to hear what you think as well. So certainly text your answers. You can also submit the code to the website. So HTTP, if you guys have laptops and you'd prefer to do that, pollev.com. Okay? So I'm going to do this occasionally throughout the term just to get an assessment of how you guys are feeling. It's another way for me to say, how was my teaching? Because sometimes I'm going to quiz you in class. I'm going to teach you a concept, and then I'm going to put up a poll and see how you guys are doing. Because oftentimes, what I find is that I say, any questions? How you guys doing? And the blank stares could be either confusion, boredom, who knows what. So this way I can better assess how you guys are feeling with the material, and if you guys are not answering obviously the multiple choice questions, majority of you are not answering them right, I know that I need to reteach that concept. Or you need to go home and think about it, and I'll re-poll you the following class. So we have 78 results. Anybody still going? Anyone still going? Okay? Yeah. So as long as you have texting, unlimited texts, you should be fine. If you pay for text, please don't do this. I don't want you to be spending money. Is that what you mean? Yeah. So as long as you have an unlimited, or you know that you're within a certain amount. Otherwise, you can go home, and I will always keep these polls open, so once you get home, if you want, I can give you the info, and you can go online and submit your response. So we're good? All right. Does anybody want to take a guess where the majority of the students are sitting? 2? Okay. Yeah. All right. So there you go. We have 7% of 80 students. So that's what? Somebody math, please. 3 or 4? That are totally freaked out. Don't worry. We'll help you, okay? Most of you are a bit nervous, and you think you can handle it. That's awesome. I'm really glad to hear that. And for those of you totally freaked out, those science whiz and nerds, there's lots of you in here, or not lots, but a few of you. So if you're willing to help out your fellow students, please. I'm a big fan of peer-assisted learning. So certainly, what? Oh, it was you guys. Right. Duh. Okay. Yeah, so there's your peer-assisted learning. Okay, good. Glad to see this. So I'll keep this open, and so somebody can remember where we're at, and I'll see how, when the V-section students, or T-section, I can't remember what it is, log in, I'll see how this changes. So everybody's cool with this technology. Some people, they can't actually do it on their phones, so I would recommend that you do the website thing. Or you can do it via Twitter. So if you go on the Poll Everywhere website, they'll tell you there's lots of different ways that you can do it. So what to expect in terms of the exams. So we have 2 midterms in this class. So the evaluation is based on 2 midterms and a final exam. Your location is to be determined. So the date of midterm 1, which is in the course outline, is Sunday, October 14th. So we have our exams on the weekends because of the guys and gals that are online, right? So we have to accommodate all these students to come in on the weekends. So sorry, your Sundays are going to be with me. Carleton University Online, or COOL, are the ones that organize it. So close to the date, they'll send me an email, and I think you guys, and let you know where it's going to be. It'll be on campus somewhere. It'll take you, I write exams that should take you probably about an hour and a half to write, but you have 2 hours to write it. The format of my exams are generally the same. Multiple choice, definition of terms, figure labeling, and short answer. A note on this. How many of you have written an exam before where you've actually had to write something out? Good. I hope you guys, it's the same. Because what I find is that a lot of students get used to the multiple choice, which is a very different kind of assessment than actually something like a definition or short answer. Multiple choice is a recognition-based task. These other ones are recall. You can study at this level and do okay with a recognition-based task, but you need to study a lot deeper to do these recall, right? Because you're writing something out. The answer isn't there in front of you and say, oh, right, it's C. I remember that. So a word to the wise, this is also a problem that I noted last winter, that a lot of the students were not doing well on these written-based exams. And this is why I also strongly encourage you, if you think you've done well and your mark does not reflect your studying and what you felt you did, that's when you go see your TA, because after the midterms, they're going to be holding office hours. You go through your exam with your TA, and it could very well be that you are assuming way too much from the TA. And that's what I find is the #1 common error, is you see a student that gets like 0.5 out of 2 versus a student that gets 2 out of 2. This is a very surface answer. This question is a lot more deep. And so it's really worth your time to go through that with your TA and ensure that you're actually writing enough or writing the detail that is needed. Don't assume your TA knows what a synapse is. Define it, for example, right? It is worth 25% of your grade. That's your first midterm, and 35% for your second midterm. If you are ill, it happens. You need to notify me, number one, within 24 to 48 hours. That is university policy. Do not email me a week after the date and say, oops, I was sick. You'll get a 0. You need to contact me and let me know, because what happens is then I assess whether you've met the criteria to write the deferred exam, i.e. you have a sick note or death in the family with a documented funeral notice, etc. If you have the appropriate documentation, then you'll be allowed to write the deferred exam, which will be approximately a week later. Please take note, number one, you need to have your student ID. You need to have your student ID when you write the deferred. If you're there sitting, you also need to have it for the original, but I'm there, right? I'm in the midterm with you. I'm not there for the deferred exam, and the proctors that are hired by CUOL will not let you write without your student ID. Okay, so I can verify, yep, that's my student if I'm there, but without a student ID, they won't let you write. So I had a couple students where that happened last year. So number one. Number two, we are no longer accepting medical notes from the Apple Tree Clinic because this actually is university policy starting this fall, because it was discovered that Apple Tree was giving out notes for hangnails. Not an appropriate reason to miss an exam, folks. In fact, it's actually documented policy that doctors should not give sick notes for students with colds or flu. That's what's in the books. So in order to miss a midterm or an exam, it has to be something quite serious. That's according to the university policy. That said, I mean, it's a judgment call. If you really can't get out of bed, your fever's 104, you shouldn't be writing an exam. You shouldn't be exposing everybody to your illness, right? So that's written in university policy, but do make a judgment call for yourself. Just a few cases of the sniffles, you should be fine. So the makeup exams, the deferred exam, is organized by CUOL. So you'll get notification once I put you on the list as to where that's going to be and the time and location. Because it's not it's not the Sunday after. It could be the Friday night, it could be the Saturday. The final exam is cumulative. What that means is you are going to be tested on everything from today to the last day of class in your final exam. Midterm 1 only covers the content prior to midterm 1. Midterm 2 is between midterm 1 and midterm 2. Obviously, there'll be a greater emphasis on the material that you haven't been tested on yet, but you are tested from everything. This isn't to be cruel. Trust me. It's not to be mean. It's to help you. The stuff that you learn, particularly in the first third of the class, synapses, neurotransmitters, that's the foundational stuff. If you don't grasp it, you're fucked. Seriously. Right? And what we noticed is the students that didn't do well on exam 1 really struggled with exams 2 and 3. Because if you can't get the very basics, you're going to have a hard time really grasping the higher level material. So I've decided this year to do a cumulative exam because I'm hoping what that means is if you don't do well in midterm 1 or midterm 2, you will really hopefully access your TAs or myself to get extra help. Because you'll know, hey, I really need to know this for the final exam. So I apologize for my swearing. Sometimes if you have Victorian sensibilities, I apologize. But sometimes I drop the F-bombs. So it's cumulative. There'll be greater focus on material post-midterm 2. It will be during the scheduled exam period. It will be 3 hours in length and worth 40% of your final mark. So as you'll see, it's incremental how much the exams are weighted. That's purposive because hopefully by the final exam you'll really get a good sense of my exam style, and hopefully you'll be doing better and better as the exams go on. The format is similar to the midterms: multiple choice, definition of terms, figure labeling, and then we're going to have some short and long answer. So don't worry, I'm going to provide you some practice exam questions. I'm going to tell you what I mean by a long answer question. We'll get there, and this will all happen before the final. We do, I don't know, we will have, before both midterms and before the final, the TAs aren't holding regular office hours. They will meet with you by appointment if needed. But what we do have is the night before the midterms, the TAs are going to use this Big Blue Button technology. So what's that going to mean is that we're all going to log in to Big Blue Button at, say, we'll have clearly defined hours. So between 7 and 8, it'll be Rob and Kristen. Between 8 and 9, it'll be Brianne and Shayna. And they'll be sitting there. It'll be like a live chat. So they'll be there waiting to answer any of your questions. So you literally will log in. If you have a question, the TAs will be there to answer them for you. Everybody understand that? You guys are like the Facebook generation, so it should all be clear to you. I haven't figured out how to use Big Blue Button yet, but I will. And once I figure it out, I'll let you know. And that'll happen before the midterm. And we'll also do it before the finals. All right, so what are the course objectives? So by the end of this term, you should have a solid understanding of the link between brain and behavior. As a biological scientist, as a neuroscientist, I believe in the brain theory. The brain theory very simply says we behave because our neurons fire. The root of behavior is in our brain, right? And this comes from 3 sources of evidence. The evolution of brain and behavior in diverse animal species, which we'll talk about next lecture. How the brain is related to behavior in normal people, right? So we know that when I'm walking, my motor cortex is firing. My premotor area lights up. If I have damage to parts of my motor cortex, you're going to see changes in my ability to walk or write or drive a car, right? So we know the relationship between brain function and normal behavior and what happens when we have damage to the brain and how that leads to abnormal behavior. So throughout the course, we'll touch on this in the beginning. Most of the course will be here, and then the last part of the course will be here. So those are the course objectives. Any questions? Yeah.
Like, I didn't take biology and stuff in high school. Like, how much are we going to be expected to know things that people learn, like, in grade 12 or something like that?
The answer to that is yes and no. I don't expect you to know it, but as a BA Psych student, you are accepted into Carleton without having those science classes. So we wouldn't make you take a class where we require you to have that knowledge base. That said, there are going to be times where I may assume knowledge that is not there. And that's my error, not yours. So if that ever happens, if you're like, whoa, 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 I don't know what electrostatic pressure is, please say, I don't know what electrostatic pressure is, okay? Because it's been a while since I was in your seat. So I don't expect you to know it, but sometimes I might accidentally do that, okay? So don't worry, I'll take you there slowly. And we will have that review basic session. And you'll see after a couple lectures that there's nothing you can't do, really, as long as you work. So why study brain and behavior? Why are we here? Why do we care? Very simply, many behavioral disorders can be explained and possibly cured by understanding the brain. Alzheimer's disease, depression, anxiety, schizophrenia. We do have a focus on mental illness. I'm sure all of you are here today because of that. Very few students take psych or neuroscience if they don't care about what causes mental illness and disease. In addition, the brain is the most complex living organ on Earth and is found in many different groups of animals. Well, again, we'll talk about phylogeny a little bit next class. But your brain it controls everything. It controls your liver, controls your heart, your respiration. Without a brain, you're what? Brain dead, right? Your body, you're breathing, your heart's pumping to some extent. Artificially, actually, with the machines that we have nowadays. But you're not functioning, you're not walking, you're not talking, right? So it is the most complex organ. And in addition, how the brain produces both behavior and human consciousness is a major unanswered scientific question. So we need you in our neuroscience army. We need you to help us figure this out. There are lots of unknowns in this field. We know a lot about physics, right? Some might say that all the important questions in physics have been answered. Others would argue that, of course. But there's so much about the brain and behavior and consciousness that we don't get. We don't know what is consciousness, for example. We can theorize about it. But what does it mean to actually be conscious? I don't know. Do you? Do you? It's like, what was that kids show where they talk to the animals and they wait for them to answer? That's what I feel like with the V-section students. What's that, Marigold? So what do I mean by behavior, first of all? A couple slides. Very, very simple, right? So here we're getting into a bit of course content. What is behavior? All of us can kind of think about what I mean. But this guy here, whose name is virtually impronounceable, and I will not even attempt it, very famous ethologist, actually. And ethology is the study of behavior in non-human animals. We actually have adopted a lot of ethological methodologies in behavioral neuroscience. And it's called neuroethology. But this guy, Earnaus, blah, 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 suggests that behavior consists of stable patterns, or not stable, but patterns in time. Right? That's the very broad definition of behavior. So you think about sleeping, walking, talking, chewing. There's consistent behaviors over time. It's a very broad definition. These can be relatively fixed. Another way of saying that is they can be innate. Anybody know what do I mean by innate? Yeah. We're born with them. That's right. What's your name?
Emma.
Emma. That's right. And if it's innate, it means that somehow it's encoded in our genome, right? It's based on, to some extent, heredity. Can anybody think about an innate behavior? Dave.
Well, I guess walking would kind of be in between, because like if you don't learn to walk, then you can't walk. But for the most part, it's a developmental thing. And it's more of an innate ability.
That's right.
So you do learn it to some extent, but you aren't born with the ability to learn it quite easily. I guess.
Yeah. So one might say that the motor patterns are innate. We're born with the ability to walk, but if we're kept in a shoebox and tied during a critical period, and we'll talk a lot about critical periods, then we may never learn to walk. Another related example is speech, right? Steven Pinker, Noam Chomsky argue that language is an innate human capability. We're all born with the capability to produce language, but we have to have specific input during a critical period in order to produce language. Behaviors are also, they can be relatively flexible. So we can go from innate to flexible, and these depend on learning. So anybody think of an example of a flexible behavior that depends on learning?
Dancing.
Dancing, right. What's your name?
Chloe.
Chloe. Dancing. Another one?
The one out of the textbook where it's the mouse or the rat has to teach the smaller ones how to properly use the pencil.
Someone's been reading. What's your name? Rebecca. Thank you. Excellent. So here's a visual that in an animal species that shows very nicely the difference between an innate behavior and a learned behavior. So in this species of bird, a crossbill, the beak is has evolved, right, due to selection pressures, to be crossed like this, hence crossbill. And it's specifically designed to open pine cones. Oh yeah, I forget with TV I'm supposed to actually use the mouse because they can't see the, so here. You can see this is specifically, back, designed to open pine cones. So that's innate. By contrast, this baby roof rat here, which is what Chloe and Rebecca was talking about, is that it's not innate to learn how to eat pine cones. Instead, the mother teaches them how to kind of unwrap the pine cone and eat it appropriately. There's lots of, I used to teach a special topics course called animal behavior, and there's lots of really fascinating examples in the animal kingdom of animals learning to use tools. For example, dolphins will grab sea sponges and put them on their nose. Well, not put them because they don't have arms, but they'll get them on their nose and they'll start foraging for food with the sponges on their nose. Anybody know why they would do that? Chloe.
Attract or absorb any fish, plankton, anything that can get their head.
Good guess, but no.
Blocks the nostrils so they can. No.
Another good guess. Protect themselves, right? So a lot of things on the seafloor are sharp. So they actually protect their snouts from being cut using these sea sponges. And the mothers, not the fathers, the mothers teach the babies how to do it. So it's only a recently evolved tool use. So that, again, is an example on learning. And you can imagine that the more complex the organism, the more learning that we're capable of, right? So the complexity of the behavior varies considerably among different species. More simple nervous systems tend to have a more narrow range of behavior. Think about sea slugs or amoebas. And most of their behavior depends on heredity. If it's not in the genome, they're not going to do it. By contrast, a more complex nervous system, much like humans, right? We have a brain, a spinal cord. Not only do we have a brain, we have hemispheres to our brains. We have 2 hemispheres that can do independent things. So very complex nervous system compared to, say, something like a sea slug. And therefore, we have a wider range of behaviors that depend more on learning. So that flexibility, that ability to take in more information from the environment is both awesome and terrible, because the terrible aspect means that lots of things can go wrong, right? And some argue that mental illness is the payment that we have to have in order to have these big, complex brains. Schizophrenia is known as a thought disorder. There's often, you have auditory hallucinations. You hear voices. If you didn't have language, would you hear voices? No. So is schizophrenia the price we pay to have the ability to have language? Some philosophers can answer that, not me. So now we're going to take a tour. We went from behavior, and now we're going to talk about the brain. And this is going to be a lecture that I've compiled. This is not in your textbook. So for those of you who rely on the textbook, pay special attention. Because yes, this will be on the exam. And no, I don't expect you to know when Darwin was born. We live in an era where we can type in Charles Darwin and get a Wikipedia page that's like 7 pages long. I don't think that's the important thing for you to take home from this lecture, right? So focus on the big, broad concepts, not the mini, bitty details. So the first recorded history where we see anything written about the brain, and obviously it's going to be the Egyptians, because they invented the ability to write, right, with the papyrus scribes. So the first recorded history of anything about the brain was with the Egyptians. Everybody who hears the word Egyptians, they think what? Mummies, right? They perfected the art of mummification. So what we hear, or what we read, for those of you that can read the hieroglyphics, is that they gave a record of how exactly they went through the process of mummification. And as you may or may not know, I love going to museums and learning about Egypt because I find it fascinating, is through the process of mummification, they removed the majority of the organs. And the one organ they thought was completely irrelevant or useless was the brain. So they took this giant hook, which I have a picture of here, stuck it up the person's nose, ripped out the brain. Useless, and threw it away. It did not get packaged up with the body for mummification. So Egyptians, yeah, they did a lot. They built pyramids. They made a sphinx. They made mummies, but they really had it wrong when it came to the brain. So the next, where we're going to go from Egypt to Greece, and we're going to talk about Hippocrates, who lived before the Common Era. very early on, and he is considered the father of modern medical ethics. Anybody here want to be a doctor? Yes, so one day you will take what's called the Hippocratic Oath. And that comes all the way back from Hippocrates because he was the first one to really say, what is medicine, right? And what should we be doing as doctors? He was also the first to describe the effects of head injuries. So he was the first to really say, something's going on with this really important organ, because if somebody has a head injury, then their behavior is altered as a result of that. He also had his theory. I'm sure most of you have heard the Hippocratic theory of the humors in many other classes before. He suggested that based on an imbalance in some of the fluids of the body, that will mean that that has an influence on your personality. So this was the theory of the four humors. So for example, if you had excess of black bile, bile is produced by your liver, you're more likely to be depressive. With an excess of yellow bile, also produced by your liver, you have mood swings. Excess of phlegm, you're sluggish. And change in blood, the amount of blood, then you're optimistic and you have a tendency for mania. Now, I'm sure many of you are not physicians and many of you are not psychiatrists, but you probably realize that this theory is incorrect, right? It doesn't matter how much spit you have in your mouth, that's not going to determine whether or not you want to get out of bed in the morning. Why I mention it and why this is an interesting thing to mention in class about neuroscience, mental health, is this side of this equation. He was getting at the idea that something may change in individuals biologically to yield differences in mental states. So that is the important thing about Hippocrates, is he was the first to really suggest this. Now we know, more or less, this is still theory, that different levels, varying levels of neurochemicals, which we'll learn a lot about, may yield these states. So keeping along with ancient Greece, we go to Aristotle. And Aristotle was a philosopher, but philosophy is really the root of all sciences. And so the philosophers were really the first to think about the body. And Aristotle believed, incorrectly, that the brain was a cooling agent for the heart, and this is where the spirits circulated, or the commonest sensus. And the brain had no role in producing behavior. So he was pretty wrong about that. However, he was the first to use the term common sense. We all have probably heard this before. This person is book smart, world dumb, they lack common sense. What were you doing, what were you thinking when you did X, Y, or Z, right? And that term comes from Aristotle. That said, the term has evolved to have different connotations than what his original definition was, which is where the spirits come together, because the Latin definition is, it translates to sensus communis, right? The community of the spirits. He also was the first to use the term psyche. So you as psych students, you know that where that language, what it means. It's the synonym for the mind or an entity once proposed to be the source of human behavior. As neuroscientists, I can tell you, you can leave your minds at the door because all you need in here is your brains. There is no such thing as a difference between your mind and your brain. Your neurons firing are what produces consciousness, or your ability to think, your cognitive capabilities. There is no difference between the mind and the brain. If you believe that, then you ascribe to something known as dualism, which for those of you, I'm sure you've heard, is Descartes' theory. Mentalism is another philosophical way of thinking that suggests that the explanation of behavior, it can be a function of the non-material mind. So that's completely opposite to what we believe today, right? So according to mentalism, my ability to speak, walk, think is due to the mind. It has nothing to do with my physical body. Okay? So that is mentalism. We'll return to some a lot more of these different philosophical philosophies. Yeah. Moving along to Galen, who are now in the Common Era, or Anno Dominus. And we're now in Rome. We went from Greece to Rome. Galen was a Roman physician who worked in a gladiator school. Don't we all wish we could have done that? That would be really cool. And he treated the gladiators after they came out of the Colosseum. And he was quite correct in believing that the brain, again, was controlling behavior. Because if these soldiers had damage to their head, he noticed that there was something going on, because he did regard these wounds as windows into the body. Woo! So he figured if somebody had a massive blow to the head, their behavior was changed, this must be due to that. I mean, it's common sense for us to think of this right now, but you have to, as much as you can, transport yourself back to an era where we didn't understand nearly as much as we do today. So Galen correctly also identified 7 of the 12 cranial nerves. Anybody heard or know what a cranial nerve is? You should have learned it in Psych 1001. We'll learn it this year. You will have to memorize all the cranial nerves and their names. It'll be fun. He also was this is just fun facts, Galen was also the first to take the pulse and see that as evidence of the heart function, right? So if pulse rate is really high, pulse rate is really low, this must mean something. So Galen, his most important contribution to neuroscience was that he correctly concluded that the brain was the organ of the mind. So he was the first to kind of pull them back together, right? Because up until that point, if you thought the brain did anything, it was more controlling the body physically, had nothing to do with consciousness or thought. So following Galen, a very dark time in history is known as the Dark Ages. And this continued right up until about 1500 AD. And this was a period of religious dogmatism. What that meant is that the church defined knowledge, right? If the Pope said that the sun did not revolve around the earth, then that's what they believed, right? The earth was the center of the universe, not the other way around. So there is not really much of a scientific inquiry at this time. Some famous figures, Copernicus and Galileo. Anybody want to take a crack at? Yeah. You got your hand up? Sort of?
Sorry.
No, you were clicking your pen. You don't know Galileo? No? Oh, okay. Yes. Rebecca?
The church really didn't like him because he contradicted that the heliocentric model.
Right.
And he vanished in school. I don't know what year it was, but I didn't let him go up next to me to the telescope. And validated the product.
Excellent. Wow. Did anybody hear that? No. So so Galileo really challenged he developed the heliocentric model of the universe, and the church did not like him, so they banished him back to his hometown, which was Spain, somewhere in Spain, I want to say. And at that time, that's when he invented the telescope. Copernicus? Yeah, Chloe.
I'm not sure, but I think didn't he conclude that the Earth revolves around the sun, not the other way around?
Right. Yep. Well, they were dueling, right? Yeah. So they were against one another. So following the Dark Ages, we have the Renaissance era. And Renaissance, for those of you French people, know that means literally rebirth, because it was the rebirth of critical inquiry, right? A famous figure during this time is Leonardo da Vinci. For any of you budding artists out there, you know not only was da Vinci a very talented and gifted artist, he was also a scientist, an inventor, Some of his sketches came to the National Art Gallery, I want to say like 10 years ago. Absolutely phenomenal. He was fascinated with the human body, and he actually was one of the first people to actually use corpses to do his sketches, right? So after people had died, he would look at like the patterns of veins, for example, and the musculature of the body. So you can see one of his sketches very early sketch of what he thought the inside of the brain looked like, right? So again, you have to put yourself back into that time where we didn't have the technologies and the techniques that we have today. He was pretty good at getting some of the neuroanatomy. Here is what I would say is, yeah, I'm not even going to go there because some of you are going to start to freak out. So we laid the foundations for anatomical drawings. I mentioned Descartes a little while earlier. He was from probably the early 16th century, late 16th century, early 17th century, and you all probably know Descartes from his famous expression, cogito ergo sum, which means, I think, therefore I am, right? And at the heart of that, Descartes believed that thought made him, right? I think, therefore I am. This is what gives us the fundamental capability to be human. So as I mentioned, Descartes was a fan of dualism, which is the idea that the mind and the body are two different entities. The mind and the brain are separate. They don't really communicate. And both the non-material mind and the material body do contribute to behavior. So he did ascribe some role for the brain, but he believed the brain was different than behavior. Oh, sorry, brain was different than the mind. That said, even though this is wrong, he was the first to suggest the link between the mind and the body, to suggest perhaps that this mind did things, right? The mind controlled movements while the body supplied the mind with information via the senses. So there was just a little bit of an extra step in there, which was wrong. So we know now, when I look to all of you, I'm getting information via wavelengths directly into my eyeballs, comes to the back of my eyes, which is the retina, where we have cells, neurons, that fire in response to changing wavelengths of light. That is your central nervous system. And when I see your face, it's going to go to part of my brain that's involved in face recognition. Chloe, Rebecca, right? I've made that somewhere in my brain, that association with your face. According to Descartes, that information would have come in via my eyes, gone to the brain, but went out via the mind. You get it? So this led to what's known as the mind-body problem. It's still something that is battled today. Because despite the fact that you all say, yeah, no, I understand, right? I get it. The mind and the brain are the same thing. I do a little thought experiment in one of my third-year classes where I get them all to imagine that it's the year 3000 and I've put your brain in a jar and it's attached to this amazing supercomputer that can stimulate various parts of your brain, and whatever you want to do, you can experience it in this jar. You want to go kite sailing in South Africa, you can do it. You want to go visit the sloth sanctuary in Costa Rica, you can do it. You want to go on a date with Justin Bieber, you can do it. And then I ask the students, I say, you have this technology. Would you prefer to have your brain in this jar doing whatever the heck you want, or keep your brain in your body? What would you prefer? And everybody says they like their brain in their body. Thank you very much. That's how it came, and that's how it's going to leave. What's the friggin' difference, I ask you, right? Why do you want your brains in your body? Because you're dualists. You think that there's something special about having your brain in your body, that it's going to be doing special things. But it would be no different than existing in a jar. Your brain is the root of your consciousness. It is your reality. So this mind-body problem was heavily debated, hotly debated. And as I mentioned, it really at the root of it is that there is this juncture where information is transferred. And according to Descartes, this was called the part of the brain where the mind existed was the pineal gland. And we'll talk about the pineal gland because it does exist, and we do use it. But it controls our circadian rhythms, our sleep-wake cycles. It has nothing to do with the mind. So according to Descartes, the mind regulated the behavior by directing the flow of ventricular fluid, which is, we'll talk about the ventricles 2 lectures from now, but essentially they're fluid-filled cavities in your brain that help cushion the brain or protect it from damage. So they knew that the ventricles existed. There was this fluid circulating throughout the brain. But rather than ascribing the role of cushioning the brain, Descartes believed that behavior occurred by directing this fluid throughout the body, much like a fluid in a pipe. And we know now that this was wrong. So some problems with Descartes. Obviously, like I said, the pineal gland exists, but it controls circadian rhythms. Fluid is not pumped via the ventricles to control movement, as that's completely incorrect. And non-material influences, for those of you that are physicists, on the body would violate the law of conservation of matter and energy. So scientifically, these theories fell flat. But there was a huge period in time, something like 50 to 70 years, right? A lifetime then ago, right? That people believed these kinds of things. Another important figure, quite fascinating, was Luigi Galvani, an Italian physiologist. And he was the first to demonstrate that your nerves, and we'll learn a lot about this 5 lectures from now, your nerves conduct electricity. They're not pipes, right? So you will have learned in Psych 1001 that the neuron has electrochemical properties. We'll talk about the electrical properties first, and then we'll move on to the chemical properties. But the first person to demonstrate that it had electrical properties was Luigi Galvani. And this was totally by chance. So they say science is serendipity. Serendipity is a synonym for chance. So what happened was Luigi Galvani was working in his lab, and this is actually a diagram showing his lab setup back then. And he was studying the sciatic nerve, which is the nerve that runs all along the inner thigh of the frog. And it's not important, the exact experiment that he was doing, but essentially the sciatic nerve was dissected open. And the frog was being kept alive artificially. And what happened was his assistant had a scalpel which accidentally drew a spark. And when he took this charged scalpel, which is metal, so it can conduct electricity, and touched it to the sciatic nerve, the frog's leg jumped. Boom. Right? Because what did it do? It artificially stimulated the nerve, which controlled the contraction of the leg. So they say chance favors the prepared mind. Galvani, being a very astute physiologist, figured this was something. He was onto something. And sure enough, through subsequent experiments, he demonstrated that nerves indeed have electrical properties. They conduct information based on their electrical properties. So another concept that took a long time to get to, now we're moving to the 1800s, was the idea of localization of function. So up until this point, people believed that the brain was one big glob. And I guarantee you, most of you had the same ideas before you started university, that the brain just did things, right? Localization of function is the concept that says your different part of your brain, you have only one brain, do different things, right? Your occipital lobe, the back part of your brain, is what controls vision. Your frontal lobe, this front part here, is involved in goal-directed behavior, planning, inhibition of behaviors, right? And so localization of function is the hypothetical construct that the control of each kind of behavior is done by a very specific area of the brain. So not all parts of the brain do the same thing. I used to teach a course called Addictions. I'll be teaching the neurobiology of addictions sometime in the future. And that's why different drugs do different things to you. When you drink alcohol, you're going to have a very different feeling than when you take cocaine. And that's because alcohol works at different parts of the brain than cocaine does. And the first kind of hint at localization of function was by Franz Gall. Franz Gall invented the study known as phrenology. And so this is in the background here. This is Franz Gall, one of his diagrams. And he believed that you could, through the process of phrenology, he'd bring you into his office, he'd charge you a lot of money, and he'd start palpating your head. And he'd feel your skull. And based on the bumps in your skull, it was like the first tarot card readings, right? Palm readings, because he said, oh, you've got a bump in behind the front of your forehead here. That must mean that you have good memory. Right underneath your eyeballs, good language. In the back of your brain here, philoprosentiveness. God knows what that means. Right? There's one here. My favorite is suavity. The more suave you are, and it's not in this one, but I'm sure some of you have seen they're all over the place now. You can buy them at Bed Bath & Beyond, those little like mannequins of Franz Gall's phrenological brains, right? Yeah, question back there. Yeah, I expect you to label it. No. Yeah. No. So Franz Gall developed this science, very loose here, basically that the mental and moral faculties were determined by the shape of the skull. It's no different than tarot card readings. It's not correct, right? He was actually, like all the rich and the famous, the aristocrats came to Franz Gall to get their readings done. And then it was found out that he was like a fake or wrong, and he was driven out of the city. The important thing, however, is this first hinted at the idea of localization of function, right? So I say this is a brain, a cartoon of a brain with lots of different spots, different anatomical regions, highlighted by dots or stripes, and labels, right? Saying, okay, here's where we know we feel pain. This is the part of the brain that is involved in smell. Also this part here, part of your frontal lobe. Spatial working memory, right here. Motor preparation, motor execution, etc., etc. So through new technologies, such as brain scanning, right? And I'll talk about that when we get to chapter 5. So PET scans, MRIs, fMRIs. We now know which parts of the brain are important or involved in various functions. We also know based on brain damage, right? So people who have acquired brain damage in adulthood or have a stroke, you get in a car accident, you bump your head, you lose a function, and we scan your brain, we see what part has died, we can more or less say that part of the brain must be somewhat important, directly or indirectly, with that behavior. I'll just go a couple more slides, and then I'll finish the rest next class. So moving to France now, Pierre Florenz, who is pictured here, was one of our early, I would say, behavioral neuroscientists. What he was really interested in doing was, what happens if we remove parts of the brain? How does that affect behavior? So he used what was known as experimental ablation. You can imagine that this was quite controversial at the time. So he worked a lot with birds, and in chickens in particular. And what he did was he removed part of the brain and observed what behaviors remained. How many of you heard that we only use 10 to 20% of our brain? How many of you heard that, right? When you survey PhDs, you wouldn't believe how many people still believe in that idea, that we only use 10 to 20% of your brain. You know where the idea comes from? This guy. Because what he did with his chickens is he removed large portions of the neocortex, and you'll learn what that means, but basically large chunks of the front part of the brain. So only the very back portions of the brain were left. And what he found was, oh, the chickens, they're still, they may not look for food, but if I put food in front of them, they'll still peck at it and eat. They'll still walk. So he concluded, we don't use a large part of our brain. And therein, that myth of we only use 10 to 20% of your brain came in. I'm here today to tell you that that is false. So when you see it on an exam, you will answer correctly. Right? Paul Broca. Anybody heard of Broca? Yeah. A lot of you with psych, you would have heard of Broca. He was also one of the pioneers of this idea of localization of function. He was a neuropsychologist, and he observed a patient who had stroke or damage to part of the brain. So stroke literally means that the blood supply to various parts of your brain has been cut off. So without blood supply to nourish the neurons, they die. And essentially, one of his patients lost the ability to speak. And the only thing he was able to say was tan, 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 tan. And he became known as TAN, the patient TAN, T-A-N. When Broca did the autopsy, what he noticed, and here is the actual brain, it's still preserved, it's kept in a museum somewhere in France, I think. He observed that part of the right hemisphere was missing. So right in behind the temporal lobe, so it's called the temporal lobe because it's in behind your temples. So I should say the right side of your brain. And he noticed that that was missing. So Paul Broca made the conclusion that that part of the brain is gone, speech is gone, that part of the brain must be important for speech. And sure enough, when he concluded that that area was not only important in speech comprehension, because Tan could understand things, he just couldn't say things. So that part of the brain, which became known as Broca's area, must be important for speech production. And sure enough, to this day, this is absolutely recognized. If I took you into the OR and gave you a local anesthetic and cut open your brain and stimulated Broca's area, it would make you produce speech. It wouldn't necessarily be sensical speech, but you'd start to blah, 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 because that's the part of the brain that sends information to the motor cortex, which directs movement of your lips and produces speech. With that, I will end, and I will say we will see you next Tuesday. We'll continue this, and we'll also talk about evolution of the brain. Have a wonderful weekend. I look forward to getting to know you all this term.